Yeah, I suppose it falls under homeowner's policy. Yeah. Okay, so from here on down, okay, solubility-wise, what can you tell me? What is the difference between the solubility of the blue compound and whether you say maroon or red? You don't need to write those down. We just want you to recognize one of them is soluble in water, the other one is insoluble. Why are you right when you say the bottom one is soluble? Okay, because when we look at each and every one of these bonds in this octanoic acid, I think, sometimes I'm counting them as I go. 1, 2, 3, 4, 5, 6. I should have went with my first instinct. 7. Heptanoic acid. And this, I believe, would be 1, 2, 3, 4, 5. Sodium purate, maybe. I'm trying to base it off of what is in the book, but not that we want you to be able to name this one, of course, but the idea behind this is ionically bonded because we've got this positive ion here, and then on this side, we've got this negative ion. You could look at it that way. Now, and it's not that this is polar. It's not. It's ionically bonded. This is where the polarity comes from this molecule. And this is why we say it's all about the water when it comes to these reactions, because this oxygen pulls this electron in just a little bit further than it would for, let's say, something like that, okay? That does not have partial and negative sides, partially positive, partially negative, okay? Even though these are all in column 1, water is such a unique compound, okay? Of course, we all know it's one of the few ones that, should you have cracks in your cement or your foundation, water gets in there this time of year, what's going to happen at night? Yeah, it's going to freeze and expand. Water is one of the few liquids that most liquids just don't do that, okay? So this is what we mean by partial, okay? And this is what makes soap work the way that it does, okay? Because when it comes to these are all covalently bonded. Again, this is ionically bonded, and it works better with that polarity of water, okay? This is a nonpolar compound. This is a polar compound because of these partial charges, and of course this is an ionic compound, okay? Now,
What are the little things?
means partial, okay? That's what we're talking about with this. There probably is no net difference between, even though lithium and hydrogen are both in the same column, you're not going to have that partial pulling of the electrons towards this oxygen like you do in here. You don't see that with lithium, but you do with hydrogen, okay? Maybe it's because hydrogen's so light. Perhaps take your pick. I really don't know. I just think that this is the best way to describe that, and again, that's why this works with that of soap. Okay, now, when you do this in college, are you going to have to explain that at a more in-depth level than what we do? Possibly. That is some of the things that is sometimes concerning that we look at on this end, but our approach is, when it comes to those flow charts that you have, it's kind of like being able to see the opponent's playbook. You already have the answer. You just have to figure out how to get there, okay? And what we mean by that when it comes to these oxidation reactions, okay, whether that's making benzoic acid or when nitration reactions take place with benzene, could be any one of those aspects. Maybe you have to show where the ions are formed or where the negative and positive charges are. But we take the approach, you know what's going to happen, but you may have to describe it at a deeper level next time. And what I mean by next time is the next level. Okay. So, and I shouldn't have erased this because this has a specific name, okay? What did we call this? Well, you could say that, but no, because that's much bigger. You're given a specific name. We just want a very general name. It's the process that we said, okay? It's a what type of, because if this is a carboxylic acid, which it is, carboxylate salt, that's right. And the reason that it's called a carboxylate salt is because of this ionic bond here. Okay, so we want to go on just a little bit. I don't know if we'll get to those books that were handed out to you, but starting this is what the important aspect was to go over. Now, because yeah, agreed. Okay, and one of the things we talked about how this is different than that of hormones is hormones are all covalently bonded, so those are lipids. Lipids are insoluble in water, but carboxylate salts, because of having that sodium or that potassium, makes that able to be delivered and more efficient for absorption into the body. Okay. So what we will do at some point, we'll take a vegetable oil, which would be considered as a fatty acid, okay? So anytime you're talking about aliphatic chains, it's everything except a ring structure or a benzene ring. Aliphatic change just means it's carbon, 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 all in a row. So when it says carboxylate salts here, this is the end product that we're looking for, okay? So what that means then is these fatty acids are obtained from animal fats, plants, and oils. So what you would do on the farm back in the 30s, 40s, 50s, 60s, and maybe, I don't know if it was so much into the 70s, is an old phrase when it comes to that of pigs and butchering pigs or these animal fats. Ask your grandparents when they would say, when it comes to utilizing pigs, you use everything but this.
Ears, the snout,
No, it's a joke though.
the eyes.
No, you use everything but the oink. Yeah, see that's where the joke comes from because you ever heard of ham hocks before? Is that the pig's feet?
Hocks.
Yes.
Back of the leg.
Okay, but it's part of the legs. I'm sure there's other less desirable portions of the pig that was utilized from one time in U.S. history to another, but you had to make use of your resources. These animal fats, certainly pigs were a good source of that. So you boil that down, you collect that animal fat, and rather than buying pure sodium hydroxide, it was commercially known as lye, okay? It's the same thing, LYE. So in this case, we're doing this same a similar process, but we use vegetable oil, which is substituting these animal fats, okay? And then with this sodium hydroxide, we go through this process of saponification, okay? Process of obtaining these carboxylate salts from vegetable oil, okay? And different types of fats. And sometimes the results are good, sometimes they're not quite what we would have expected. All right. Okay? So when it comes to cleaning agents, which these different types of soaps would have worked, okay, this dirt is combined with body oils or grease, it still does an all right job of cleaning that. Probably not as good as you could say maybe diesel fuel or gasoline. I wouldn't suggest using those anymore, but that certainly would have cleaned your hands then as well. Okay? Because when we look at grease, okay, not John Travolta and Olivia Newton-John, not that grease. Yeah,
Olivia Newton-John, like the singer?
yeah, yep,
Never
yeah.
seen Grease?
I've seen grease before, but okay. But what happens then? These substances are not water soluble, but the carboxylate salt then makes it so you can break up those bonds and then wash it away. Now, the degree of a nonpolar compound like grease and oil as opposed to paints and varnishes and stains, that I really can't really answer, but I don't think any type of soap really works very well with varnishes and oils-based paints. But as far as grease is concerned, that will do the trick. And that's what we're going to read in the book if we would have had time. But other, I wouldn't call them interruptions. Picture taking tasks, is that what you want to call it? Or did you say obligations? That's a good term right there. Yes. Okay. So other obligations kind of got in our way. We're not going to get done as much as what we would have liked, but now we will see where it is that we will start then on Tuesday, which is this part. We're supposed to get to that today. I didn't think we would get to it yesterday, but and that's okay. All right. And then we will start with this on Tuesday. And then should time allow, maybe in the lab, would you rather do, and you're not going to know the answer to this. There's no right answer to it. It's just, you got to, what sounds, what do I want to say, more interesting to you, esterification or carboxylate salts? And carboxylate salts means soap. So esters or soaps? Soap. No, we don't make ethers. Yes, I caught that.
Why not?
Because he's saying he doesn't want to do one or the other. It's either. Ether, either. Oh, well, we don't have the ability to do that. Yeah. Salts. Salts. Okay, salts it is. We'll go ahead and try to get those started. Maybe a week from yesterday would be a good day. I don't know. We'll try to look at that moving forward. And if I'm not mistaken, I do need to get vocab terms to you, correct? Oh, you do have them. Okay. So, because sometimes I get them handed out, like zoology, I had to go back and find them and get them handed out. So yes, next week we'll start with this process of esterification, and that has its own neat little activity with it as well, which is why having these days is important, that we give you the tools to be successful next time you see this. All right, that's all I have. We'll catch up to you next time.